Welcome to another exciting advance in the history of welding. High-quality, high-endurance welding has found wide application in the manufacturing and repair of everything from bicycles to race cars to aircraft and aerospace products. That puts you on the leading edge with your new Square Wave TIG 175 welder from Lincoln Electric, world leader in the manufacture of arc welding and cutting products. Gas tungsten arc welding, or GTAW, is also known as the tungsten inert gas process, or TIG welding. Heat for welding comes from an electric arc crossing between a tungsten electrode and the workpiece. The arc zone must be filled with an inert gas, usually argon, to provide a conducting path for the arc current and to protect the molten metal and electrode tip from oxidation. It won't be long before you'll be making quality welds on mild steel, stainless steel, and aluminum with your Lincoln Electric Square Wave TIG 175. The first step is to read your operator's manual fully. Then review it again, with special emphasis on the safety sections. Your Square Wave TIG 175 is a constant current arc welding power source designed for AC and DC TIG and stick welding with a 12 to 175 amp range. Controls are simple and easy to operate with Lincoln's exclusive internal auto balance feature for AC TIG welding. You'll automatically have the right amount of cleaning and penetration over the full current range. With your new machine, you should have the Magnum LA9 TIG torch with quick connect plug and integrated shielding gas connection, gas nozzle, 3 32nd-inch collet and collet body, long and short back cap, and a 3 32nd-inch 2% thoriated tungsten electrode. An outstanding bonus with your 175 is the convenient foot control for precise automatic control of weld amperage for quality welding. You'll also find an adjustable Harris argon gas regulator and flow gauge with a 10-foot hose, stick electrode holder with a 10-foot cable, quick disconnect plug, stick electrode samples, and work clamp with a 10-foot cable. You'll also have a 6-foot input plug and cable assembly, along with a 230-volt input receptacle, which must be installed by a licensed electrician. Don't forget, electric shock is most dangerous on the input side. Electric welding current flows from the machine through the torch cable assembly and the tungsten electrode, and across the arc. On the other side of the arc, current flows through the base metal to the work clamp and back to the machine. This circuit must be complete to have an arc established. Other equipment you should have includes a welding helmet with filter lens, pliers for picking up hot metal, a chipping hammer, wire cutter, safety glasses, wire brush, clamp, fire extinguisher, protective clothing, and special leather gloves for TIG welding. To help you be a better welder, it's good to review base principles behind the GTAW and SMAW welding processes. The heat for arc welding is created by a special electric arc that we have optimized through a century of experience. With GTAW or TIG welding, the arc is maintained between the tungsten electrode and the base metal. The electrode is not consumed. Heat fuses the pieces together. Filler metal is used for horizontal butt welds or with poor fit-up situations. In SMAW or stick welding, the heat from the arc melts the electrode end and the base metal. As the end of the electrode melts, it flows into the weld joint as filler metal. No matter what type of welding, the molten weld puddle must be protected from oxygen and nitrogen in the atmosphere. If not, weak, porous welds result. Flux coating on a stick electrode melts to provide the shielding gas protection and a slag covering for the deposited weld metal. In the TIG process, argon gas shields the arc. Gas flows through the regulator flow gauge, the solenoid, and the torch hose and nozzle. When the current shuts off, gas continues to flow for 15 seconds to protect the weld puddle. Now that you are familiar with your new Square Wave 175 and you've carefully read the operator's manual, let's review a most important subject: welding safety. Safety for you and those around you, and the protection of your property. Your manual emphasizes precautions for protection from electrical shock, arc rays, fumes and gases, flying sparks, and hot metal, and the proper handling of gas cylinders. Your welder is internally protected by a thermostat and circuit breaker. It will shut down if amperage ratings are exceeded or if the machine starts to overheat. You should also have a separate external circuit breaker installed by a licensed electrician just for this machine. Never look directly at the welding arc without proper eye protection. A welding helmet with a number 10 safety lens for welding mild and stainless steel and a number 11 lens for aluminum is required. Proper clothing is critical. Long sleeve shirt buttoned at the collar and wrists, protective jacket or shop coat, and dry hole-free leather gloves for TIG welding. Wear pants without cuffs and high-top leather footwear. Wear safety glasses at all times. Be sure to have your work area properly ventilated and keep your head out of the weld fumes. Avoid fire hazards by keeping your workplace clean and free of fuels, chemicals, paint, solvents, and other easily ignited materials. Longer hair should be tied back or tucked under a hat. Of course, keep a fire extinguisher handy. To begin setting up your welder, place it on a clean, level surface or the optional undercarriage. Be sure nothing blocks air circulation around the welder. The high-frequency generator in the machine, being similar to a radio transmitter, can cause radio, television, and electronic equipment interference, and much more. It can cause damage or effectively destroy sensitive circuitry, such as computer systems and other electronics. So proper earth grounding, as specified in the manual, is extremely important. Connect the TIG Torch Quick Connect plug into the electrode gas output receptacle. This is both electrical and gas supply. Connect the foot Amtrol to the remote control receptacle. This control lets you turn on and adjust the amperage while you weld. Always be sure your argon bottle is secured so it cannot fall, as shown here on the optional Lincoln undercarriage. Remove the cap. Install the regulator flow gauge securely to the cylinder so that the face is vertical. Connect one end of the gas hose to the regulator flow gauge and the other end to the gas fitting on the back of the machine. Tighten fittings to prevent leaks. Never use oil on any of these high-pressure connections. Set TIG stick switch to TIG and the current control to the maximum amps desired. Of course, attach the work clamp. Your machine is now set up for TIG welding. To set up your machine for SMAW or stick welding, connect the stick electrode holder to the electrode gas output receptacle. The work cable and work clamp are factory connected. Make sure the TIG stick switch is in the stick position. Turn the current control knob to the proper setting, attach the work clamp, and your machine is ready to stick weld. In the world-famous Lincoln Electric Weld Technology Workshop, TIG welding training starts with practice on mild steel. For welding mild steel, the tungsten electrode end must be ground to a pencil point. Make the point binding lengthwise, not across the end. A fine grit, hard abrasive wheel must be dedicated to this single use. The tungsten electrode tip will become contaminated if ground on a multi-use wheel. Clean the weld area with a wire brush. As with the grinding wheels, separate brushes must be used for each metal to avoid contamination that causes poor weld quality. Turn the power on. The fan will run and the on light will glow. Select the TIG mode. Turn to DC negative for mild steel welding. Turn on the gas flow, adjust the flow rate. Secure the work cable as close to the weld joint as possible. Be sure it makes good contact to reduce resistance in the welding circuit. And you'll avoid extending the circuit and accidentally damaging other parts. Also, use care in preventing the electrical circuit from going through hinges, chain hoists, or electrical components to avoid severely damaging them. We'll start with a fusion edge weld. Note that the edge of the ceramic cup is touching the workpiece for perfect positioning. Power and shielding gas control is supplied through the foot control. Note that if the rheostat on the machine is set at 75 amps, it means the foot control, when fully depressed, will deliver a maximum of 75 amps, not the full machine output. This feature is especially desirable for additional control on thin material at low amperage. There's a half-second pre-flow of gas before the torch is energized. Note the counterclockwise circular motion technique for right-handers. The torch is held at a 10 to 20 degree angle to the direction of travel. Left-handers should do the opposite. At the end of the weld, the torch is held in place to protect the molten metal. Back off slowly on the foot control to fill the end of the crater to avoid crater cracks. Shielding gas continues to flow for 15 seconds after the arc has gone out. Keep the torch over the weld. Now, a lap weld with mild steel. Here, the top edge of the upper piece will be melted or fused to the lower plate. Again, circular motion as before. A clean, smooth weld. For practice with adding filler metal, let's start with mild steel. Clean the rod with clean steel wool. Note the consistent pace of the repetitive motion. The operator keeps the end of the rod within the gas-protected area. The next train weld is a horizontal fillet weld using filler metal. Again, tight circular motions, dabbing the filler metal in as needed. The use of filler metal is ideal with bad fit-ups. Let's move up to TIG welding of stainless steel. The tungsten electrode must have a sharp, uncontaminated point, and polarity remains at DC negative. The ceramic cup is positioned on the workpiece. The arc darted, and precise circular motions fuse the two edges for a smooth, clean weld. Practice again on the lap weld with filler metal. Don't forget to steel wool the filler rod first. For the stainless fillet weld, remember the steps. Position the torch. Use the foot control. Circular motions. Dab the filler rod in as needed. Pause to protect the weld puddle. The AC TIG welding of aluminum with your square wave TIG 175 offers a number of advantages. With the square wave design, the positive portion of the AC wave causes heating of the electrode and cleaning action. The cleaning action removes the heavy oxide coatings on aluminum. The negative portion of the AC wave minimizes electrode heating, so there's no spinning and more heat concentrated on the work. All this allows you to weld through the complete 12 to 175 amp range in AC TIG or DC negative TIG, needing only a 3/32 inch 2% thoriated tungsten electrode. For aluminum welding, the tungsten electrode end must be radius, not pointed. To change this square end, you'll need a thick block of copper. Set the polarity switch at DC positive. A few seconds of power, and the electrode end becomes rounded. Do not form a ball on the end of the electrode. Stay with the diameter of the tungsten. For TIG welding aluminum, AC power is required. The next challenge for your skills is the edge fusion weld of aluminum plates. Set the ceramic cup and begin, using the circular motion technique. Pause at the end to hold shielding gas on the puddle. It takes practice. As with any other activity or skill, it's mastered by repetition and experience. Setting up for stick welding of mild or stainless steel with your new machine is easy. With power off, attach the quick disconnect plug to the electrode output receptacle. Select the stick mode. The foot control does not operate in the stick mode. Secure the work clamp as close to the welding joint as possible. Set the polarity switch for the type of electrode being used, most commonly DC positive. Place the electrode in the holder. Turn on the power. Adjust the current control. Scratch start an arc and begin welding. Hold the electrode at a 10 to 30 degree angle in the direction of travel. Remove slag and clean the weld with a chipping hammer and wire brush. Should the transformer in your welder overheat, welding output will shut off and the overtemperature light will come on. The fan will continue running. Before performing any maintenance task on your welder, be sure the power switch is off and input power unplugged. Check cables for cuts and missing insulation. Replace if necessary. Damaged labels or decals should be replaced. Inspect the gas outlet O-ring for wear and damage. Look over the torch body for cracks. Check the cable and hose for damage and wear. Replace them promptly when needed for your safety. Refer to the troubleshooting page in your operator's manual for help with the problem. If you can't find the answer, contact your local Lincoln Authorized Field Service facility. With proper care and use, your new square wave TIG 175 will serve you well for years. Years producing high-quality TIG and stick welds on a variety of metals. The durable Magnum TIG torch and convenient foot control will make work efficient and enjoyable. The ease and accuracy of TIG welding will help you produce quality appearance welds if you practice the techniques we suggested. Your versatile TIG 175 converts readily to the stick welding mode. take care of your machine. Make machine maintenance and cleaning a part of your regular routine. Most of all, take care of yourself. Dress properly for welding, keep clean and safe, and strictly follow procedures established by and for welders. You'll be rewarded often by your quality-built square wave TIG 175. And should you want even greater power and versatility, our square wave TIG 255 offers full range capabilities from 5 to 315 amps. The square wave TIG 355, 2 to 400 amps. Both offer excellent programming versatility. Whatever your future needs, Lincoln Electric offers the broadest line of wire and stick electrodes, power sources, wire feeders, robotics, cut products, environmental equipment, and an extensive network of distributors, technical sales representatives, and warehousing centers. Lincoln Electric, world leader in arc welding and cutting products, starting our second century.